All right, let's get right into it. Deep inside your brain, kind of tucked away under all those wrinkly folds of the cortex, there's this incredible structure that's basically mission control for your entire body. I'm not kidding. It's not just a part of the brain, it's the central hub, the master regulator. So today, we're going to take a tour of this command center, the diencephalon.
So, have you ever wondered what sits right in between your thinking brain and the rest of your body? What's running the whole show from behind the scenes? How does a thought like, I should move my hand, turn into an actual movement? Well, the answer is this powerful, kind of mysterious region we're about to dive into.
And there it is, the diencephalon. The name itself, diencephalon, it literally means interbrain or tween brain. And honestly, that's the perfect way to describe it. It's this critical junction box that's sandwiched right between the high-level thinking parts of your brain and the more, let's say, primitive brainstem.
Okay, so let's get our bearings here. Just look at where this thing is located, tucked away deep in the absolute center. Think about that. Every single piece of information, whether it's flowing up to your conscious brain or down to your body, it has to pass through or get processed by this region. It's the ultimate gatekeeper. So if we really want to understand the diencephalon, we can't just think of it as one big blob. Nope, we've got to break it down. We're about to go on a tour of its 4 distinct neighborhoods, and each one has a super specific and absolutely crucial job.
So here's our map for the tour. We're going to visit the huge thalamus, the incredibly powerful hypothalamus right underneath it, and then 2 smaller but still totally essential supporting players, the epithalamus and the subthalamus. Let's kick things off with the biggest one on the block.
All right, our first stop, the thalamus. Look, if the diencephalon is the city's central hub, then the thalamus is its grand central station. Seriously, it is a massive, bustling center where countless signals are constantly arriving, getting sorted, and then sent off to exactly where they need to go.
And the sheer amount of stuff this thing is responsible for is just mind-blowing. It's not just some simple relay station. Oh no. Yeah, it routes sensory and motor signals, but it also regulates your consciousness, your sleep, your alertness. I mean, it is literally the reason you are awake and aware enough to be hearing my voice right now. All those jobs are connected. You can't be conscious without the thalamus sorting out the world for you.
And this just perfectly shows its role as a gatekeeper, right? Your eyes don't just talk directly to your visual cortex. Your ears don't have a direct line to your auditory cortex. Nope, all of them report to the thalamus first. It's like the executive assistant who then passes the message to the right department upstairs so you can consciously process it. And this is a really cool piece of brain trivia. There is one sense that gets a VIP pass. It gets to bypass the thalamus completely. And that sense is smell. Your sense of smell is the only sensory pathway that wires directly into the cortex. And that's probably why certain smells can trigger such powerful, instantaneous memories and emotions. It's a direct connection. Okay, let's head to our next stop, located just below the thalamus. This is the hypothalamus. And if the thalamus is Grand Central Station, then the hypothalamus is the master control panel for your entire body. It's constantly tweaking the dials, making tiny adjustments to keep everything running just perfectly. And its number one, most important job is something called homeostasis. Now, all that really means is balance. Your body loves balance. Not too hot, not too cold, not too hungry, not too full. The hypothalamus is absolutely obsessed with keeping your body in that perfect, stable, sweet spot. So how does it pull off this incredible balancing act? Well, it basically uses 3 main tools. First, it's the CEO of your entire hormone system, giving direct orders to the pituitary gland. Second, it's in charge of your autonomic nervous system. All the stuff you never have to think about, like your heart rate or your body temp. And third, and this is a big one, it generates those powerful primal drives that make you act, like the urge to find food when you're hungry or water when you're thirsty. This classic experiment with cats just shows you how specific and powerful that control really is. If you damage one tiny little spot in the hypothalamus, let's call it the I'm full switch, the cat will literally eat itself into obesity. But if you damage the spot right next to it, the I'm hungry switch, it will starve. The entire survival drive to eat is controlled right there in that tiny area. And it's the exact same idea for body temperature. The hypothalamus is like this super sophisticated thermostat with 2 different centers. The front part, that's your heat loss center. If you get too hot, it kicks in and makes you sweat. The back part is the heat conservation center. Get too cold, and it makes you shiver. It's just a perfect push and pull system to keep you at the right temperature. Now let's zoom in on one of the hypothalamus's most critical jobs, its command over your entire hormone system. And it does this through its direct connection to the pituitary gland, which you might have heard of as the body's master gland.
Now the really cool thing here is that the hypothalamus uses two totally different ways to give its orders. To talk to the back part of the pituitary, it's a direct line, like a hardwired telephone. Neurons literally run straight down and release hormones right into your blood. But for the front part, it's indirect. It sends chemical memos through a special, private little blood vessel system. It's like sending an email instead of making a phone call.
So, to make sure this whole system doesn't just spiral out of control, the body has these brilliant checks and balances called feedback loops. Let's walk through it. First, you have the ultra-short loop, where the hypothalamic hormone basically tells itself to chill out and stop. Then there's the short loop, where the pituitary hormone travels back up and tells the hypothalamus, hey, we're good, you can stop now. And finally, the long loop. A hormone from way out in the body, like from your adrenal gland, travels all the way back to shut down both the pituitary and the hypothalamus. It's this beautiful multi-level off switch.
And this is exactly why all this matters so much. When this system breaks, you get serious diseases. Take diabetes insipidus, for example. The body fails to make a hormone called ADH, so it can't conserve water, which leads to just extreme, uncontrollable thirst. Or look at Cushing's disease. A pituitary tumor starts pumping out way too much of a hormone called ACTH, and that causes a whole cascade of problems: muscle weakness, extreme hunger, and that characteristic potbelly look.
Okay, time for our third and final stop. Let's meet the other two members of the Diencephalon family. They might be smaller, but trust me, they play absolutely essential supporting roles in our brain's day-to-day performance.
So here they are, the two supporting players. First, up top, you've got the epithalamus. Think of this as the brain's master clock. It's got the pineal gland inside, which is what secretes melatonin to manage our daily sleep-wake cycles. Then, below, you've got the subthalamus. This is more of a rhythm generator, but not for sleep. It's for movement. It helps keep our physical actions smooth and under control.
And you know, the subthalamus has become unbelievably important in medicine because it helps control rhythmic movement. Deep brain stimulation of this exact area is now one of the most effective treatments for the motor symptoms of late-stage Parkinson's disease. It is just a stunning example of neuroscience in action.
So, we've wrapped up our tour, we've seen the brain's central relay station, its master control panel, and the crucial supporting cast. And I think the big takeaway here is that this small central structure is so much more than just a collection of parts. It's really the unseen hub that ties our entire experience of the world together.
This really just says it all, doesn't it? The diencephalon is that critical hub that seamlessly integrates our senses, regulates our body, and connects our most basic, primal drives to our conscious experience. I mean, without it, sensory information would just be a jumble of noise, our bodies would be a mess, and our survival urges would be completely disconnected from our minds. It's the ultimate integrator.
And that leaves us with a really fascinating question to think about. We've seen how this tiny, ancient hub masterfully runs all our automatic systems, our sleep, our hunger, our temperature, but it's also feeding all the information that becomes our conscious reality. So, where does that line get drawn? Where does the automatic function end and our sense of self truly begin?